So I try to record the process of making sounds from movements, turning dance into wind. And this happens through Python. In Python, in another script, I pre-processed a dancing video where I use an algorithm, or more like a system, called OpenPose, and they detect joints in RGB images. So I will parse the position of the dancer inside the frame of the video. I don't do it for each frame because it's quite a heavy algorithm, so I do it every 50 frames. So for every 50 frames we have the position of the joints, which eventually looks something like this. So we have the hips, the knees, the ankles, the shoulders, the neck, the elbow, and the wrist. I think there's a few more. These are all the points that can be detected, but of course the algorithm is not perfect, so it will sometimes detect and sometimes not detect certain points, or misdetect also. Many mistakes can happen. As you can see, most of the time it looks like a skeleton, but sometimes it does not, so something has been missed. Looks a little bit weird. This is to read the video. Then once we've read in the video, we can draw the skeleton onto the video. I made a slight post-processing step in which I mirrored and added an offset to the position of the skeleton, which made it look as if the skeleton was dancing with the dancer, and it's kind of cute. You can see that sometimes there is no skeleton, so the system didn't manage to capture exactly where the person was, and this is especially in more unusual postures closer to the ground. And for each skeleton position, we calculate joint angles for the knee, the hips, the shoulder, and the elbow, because we want to have somehow a generalizable representation of a skeleton. So, for example, people with long arms would have a very different coordinates of arm positions instead of in comparison to people with short arms. But we want for people doing similar kind of movements having a similar kind of sound. So that's why we convert the skeleton joint positions, so the joint positions, into joint angles. So eventually we have for each frame 8 joint angles in radians, which are these numbers. And then our sound system is this. It's a pure data patch I found online, which generates wind-like sounds through 2 parameters. So we have 8 joint angles and we only need 2 parameters. Therefore, I use PCA, Principal Component Analysis, which is a statistical method to reduce parameters in a mathematical optimal way, which means that as much information that is in the 8 parameters is kept in the 2 parameters. So you reduce the dimensionality. And afterwards, the 2 parameters that come out of the dimensionality reduction are scaled. Yes, they are scaled in a range from 0 to 1 so that we can use them afterwards and that they're nicely evenly distributed as parameters for the sound generation. They need to be, or it is better to evenly distribute them so that the sound generator creates a nice and rich sound. Otherwise, it might be that certain regions are biased in the movement. So then this is the eventual output, and we see that both parameters kind of have quite a variety, even though the second parameter seems to be bigger most of the time. This is something that is harder to control. It's inside the algorithm, but of course in later stages this can be post-processed and somehow scaled so that the range of 0 to 1 is better used for the parameters. And then it's about this is mostly straightforward, where I send the parameters frame by frame to pure data in such a way that it can be synced back to the video. And we can do a little demo. So every frame. So every new frame, there's a new posture, so there's a different sound. And because we only parsed every 50 frames, the sound changes. And that's what happens. Yeah. That's it. This is the first draft, demo, prototype thing. There's many more changes that can be done in almost every step of the whole pipeline, but the most important part was to get it from A to Z working and to have some results. And now that we have this, in the future I will try to tweak it, make it look and sound even more interesting.